everybody, hope all of you are fine. Today I am going to discuss about trigonometry of class 10th. In this class we will discuss about trigonometric ratios, what are the definitions of different trigonometric ratios, and then we'll solve some problems related to trigonometric ratios. So let us enter into our topic. Trigonometry is a topic which explains about a right angle triangle. You all know about a right angle triangle in your lower sections. So here we are going to know some new terms in right angle triangle. So let us take one triangle ABC, right angle at B. So I am taking triangle ABC in which angle B is equal to 90 degrees. I am taking one more angle, that is angle A. Angle A is equal to theta, some angle. So now based on angle theta we give different names to the sides of right angle triangle. For example, in this triangle ABC, we have angle A is equal to theta. Then BC is opposite to angle theta. So we name this side BC as opposite side to angle theta. So if angle A is theta, then BC is opposite to it. Similarly, one more side AB is beside it. That is what? Adjacent. So AB is called adjacent side to angle theta. So if angle A is theta, then BC is opposite side and AB is adjacent side. Then one more side is left, that is AC. AC is opposite to right angle. In lower sections only we know about hypotenuse, that is longest side in the right angle triangle. Right side opposite to right angle we call it as hypotenuse. So here hypotenuse is AC because it is opposite to right angle. So these are the names of right angle triangle. So naming is over. Now let us discuss about the ratios. The first ratio is sin theta. Sin theta is defined as it is the ratio of opposite side to angle theta by hypotenuse. So ratio of opposite side and hypotenuse will be called as sin theta. And the next ratio we have cos theta. Cos theta is the ratio of adjacent side to angle theta to the hypotenuse. Then we have next ratio, that is tan theta. Tan theta is the ratio of opposite side to angle theta and adjacent side to angle theta. So these are the first three ratios, and after that we have next three ratios which are reciprocals of first three. That is cosec theta, which is reciprocal of sin theta. So cosec theta is hypotenuse by opposite side to angle theta. We have secant theta and tan theta also. Secant theta and cot theta. Secant theta is reciprocal of cos theta, so it is hypotenuse by adjacent side to angle theta. Then we have cot theta also. Last one, it is the reciprocal of tan theta. Cot theta is adjacent side to angle theta by opposite side to angle theta. So these are the ratios. So now we learned about ratios. Based on these ratios, what kind of problems will be there, we will discuss. So to know, to understand all those problems, it is very important to remember these 6 ratios. Here, so what we learned here, sin theta is opposite side to angle theta by hypotenuse, cos theta is adjacent side to angle theta by hypotenuse, tan theta is opposite side to angle theta by adjacent side to angle theta, and the next 3 are reciprocals. Hope up to here it is clear to you. Let's see this problem based on trigonometric ratios. In this problem it is given sin theta is equal to 3 by 5. We have to find out all other remaining trigonometric ratios. So here what we do, first we write the given information. Given sin theta is equal to 3 by 5. Then we take one triangle. Let us take triangle ABC, right angle at B, and we also take angle A is equal to theta. Then based on this we define what is sin theta in this triangle ABC. So here sin theta will be opposite side by hypotenuse. Here opposite side to theta is BC and hypotenuse is AC. So it is BC by AC. So from these two, in question it is given sin theta is equal to 3 by 5. Here in triangle ABC we wrote sin theta is equal to BC by AC. So from these two we can write BC by AC is equal to 3 by 5. So from this we can write BC is equal to 3K and AC is equal to 5K. Here you may have doubt like why we are taking K. We take K because it is ratio, not exactly BC is equal to 3 and AC is equal to 5. 6 by 10 also gives you 3 by 5. 12 by 15 also gives you 3 by 5. So here all these values will give you ratio 3 by 5 only. So BC can be any multiple of 3 and AC can be any multiple of 5. That's why we take BC is equal to 3K and AC is equal to 5K. Once after we are writing this, we use Pythagoras theorem because we do not know AB. We find out what is the value of AB. So here what we write by Pythagoras theorem, what it says, AC square is equal to AB square plus BC square. In any right angle triangle, square of hypotenuse is equal to sum of squares of other two sides. Now we substitute the values of BC and AC in this and we will find out AB value what it is. So AC is 5K square, so we substitute 5K whole square is equal to AB square plus BC is 3K whole square, which gives you further 25K square is equal to AB square plus 9K square. From this we get AB square is equal to 25K square minus 9K square, which is AB square is equal to 16K square The 16k square we can also write it as 4k whole square. So finally what we get, AB is equal to root of 4k whole square. So square root will be cancelled. So AB is equal to 4k. This is the value of AB. So now we know the values of BC, AB and AC. BC we know 3k and AC we know 5k and AB we know 4k. Now once you know all the three sides, we can write any trigonometric ratio. So here we want cos theta because sin theta already we know. We have to find cos theta, tan theta, cosec, secant and cot. Let us write what is cos theta first. Cos theta is equal to ratio is adjacent side by hypotenuse. So here adjacent side to theta is AB and hypotenuse is AC and it is 4k and 5k. So 4k by 5k, after cancellation we get 4 by 5. This is the value of cos theta. Then tan theta is equal to opposite side to theta by adjacent side to theta, that is BC by AB, 3k by 4k. After cancellation we get 3 by 4. Cosec theta is reciprocal of sin theta. So when sin theta is 3 by 5, cosec theta is 5 by 3. Directly we can write. And secant theta is reciprocal of cos theta. Since cos theta is 4 by 5, secant theta will be 5 by 4. Cot theta is reciprocal of tan theta. We know tan theta is 3 by 4, then cot theta will be 4 by 3. So in this way we can find out all other trigonometric ratios. When one trigonometric ratio is given by drawing triangle and by using Pythagoras theorem, we can find out third side. Once you know all the three sides, all the remaining trigonometric ratios we can find out in this way. Hope you understood this. Let's solve this problem. This is another problem. It is similar to previous problem. Only the difference is what? In the previous problem it is given sin theta is equal to 3 by 5. But now it is sin theta is equal to a by b. Generally when it is a by b, x and y, students feel difficult. And remember, there is no difference whether it may be a by b or 3 by 5. We follow the same procedure. Now let's see how to solve this problem. Here also first we write given information, that given sin theta is equal to a by b. Now after that we take triangle ABC, that is in triangle ABC we take angle B is equal to 90 degrees and we also take angle A is equal to theta. Then we write what is sin theta in triangle ABC. In triangle ABC sin theta is what? Opposite side by hypotenuse, that is BC by AC. So by this what we write, BC by AC is equal to A by B. By this what we understand, BC is equal to some AK and AC is equal to BK, multiples of A and multiples of B. Now once if it is done, we use Pythagoras theorem to find out what is AB. So here what is Pythagoras theorem again? AC square is equal to AB square plus BC square. Square of hypotenuse is equal to sum of squares of other two sides. Now we substitute the values of AC and BC in this, that is BK whole square is equal to AB square plus AK whole square. Now AK whole square we have to transpose the other side to get AB square. So here we get AB square is equal to BK whole square is B square K square minus AK whole square, if you transpose that side it will be A square K square. Now from these two we can take K square common. So we get K square into B square minus A square. Now what is AB now? AB is equal to root of 4 by 5 by 3 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 by 5 by AB is equal to root of k square into b square minus a square. Now this k we can write out so that we get k into root of b square minus a square. This is the value of AB. So now we got all the values. BC is AK, AC is BK, and adjacent side is root of b square minus a square into k. Now suppose you want remaining all other trigonometric ratios we want now. So first if you want to find out cos theta is opposites adjacent side by hypotenuse, that is AB by AC. So it is root of b square minus a square by b. So here they both will be cancelled. K will be cancelled. It will be just root of b square minus a square by b. After that we want tan theta. Tan theta is opposite side by adjacent side. That is a by root of b square minus a square. Now cosec theta is just reciprocal of sin theta. Sin theta we know a by b, so it is b by a. Then secant theta is the reciprocal of cos theta, because cos theta is root of b square minus a square by b. Now it is b by root of a square minus root of b square minus a square. Then at last cot theta is reciprocal of tan theta. So cot theta result will be root of b square minus a square by b. In this way, not b, a. In this way we can find out remaining all other trigonometric ratios even if it is given a by b instead of numbers. Hope you understood this problem. Let's see, this is another problem based on trigonometric ratios. In this problem it is given 3 cot theta is equal to 4. We have to show that 1 minus tan square a by 1 plus tan square a is equal to cos square a minus sin square a. So here, like before, let's write the given information. Given 3 cot theta is equal to 4. So from this we write cot theta is equal to 4 by 3. Like before, in triangle ABC, we take angle B is equal to 90 degrees and angle A is equal to theta. So let us write this triangle as A, B, C. This angle is 90 degrees and this is angle theta. Now we define what is cot theta in triangle ABC. In triangle ABC, cot theta is adjacent side by opposite side. So it is adjacent side AB and opposite side is BC. So we write it as AB by BC. Now from these two, cot theta is equal to 4 by 3 and cot theta is equal to A by AB by BC. We can write AB by BC is equal to 4 by 3, which indicates AB is equal to 4K and BC is equal to 3K. Now we want AC, so we find out AC by using Pythagoras theorem. So what is Pythagoras theorem? AC square is equal to AB square plus BC square. In this we will substitute the values. So here AC square is equal to, after substitution, AB is 4K, so 4K whole square BC is 3k, so 3k whole square, which is 16k square plus 9k square, which is 25k square. This is AC square, but this 25k square can also be written as 5k whole square. So finally, what is AC? AC is equal to root of 5k whole square. Square root will be cancelled. So we got AC is equal to 5k. Now we know BC is equal to 3k and AC is equal to 5k and AB is 4k. We will substitute all these values. So here what we need? We need tan A, cos A, sin A to prove LHS and RHS equal. So since tan A is reciprocal of cot A, tan A value directly we can write tan A is equal to, since cot theta, okay, theta we have to write. So tan theta is equal to, cot theta is equal to 4 by 3. So tan theta is equal to 3 by 4. And cos theta is equal to adjacent side by hypotenuse. So 4 by 5. And sin theta is 3 by 5. Once we know these three values, we find out what is LHS and what is RHS. So let's find out what is LHS here. LHS we have to find 1 minus tan square A by 1 plus tan square A. Substitute 1 minus tan A is 3 by 4. So tan square A is 9 by 16. I am writing directly by 1 plus 9 by 16. Now we have to simplify this. After taking LCM, it will be 16 minus 9 by 16 by 16 plus 9 by 16. Now we can cancel the 16 and 16. So the result is going to be 16 minus 9, 7 by 16 plus 9, 25. So LHS we got 1 minus tan square A by 1 plus tan square A is equal to 7 by 25. This is LHS value. Now let us simplify about RHS also. So what is RHS? RHS is cos square A minus sin square A. So we have to substitute in this. Cos square A is 4 by 5. So when you do square, it becomes 16 by 25. And sin A is 3 by 5. So sin square A is 9 by 25. So directly cos square A minus sin square A, because they are like fractions, directly we can subtract. We get 16 minus 9 by 25, which is 7 by 25. So we got LHS and RHS are equal. So we write LHS is equal to RHS, hence proved. Hope you understood this solution also, how to solve when this type of questions are given. So this is the one video based on trigonometric ratios, the basic concepts. I am trying to do more videos on all other complicated and difficult problems in trigonometry for class 10th. Hope this video will help you a lot. So subscribe the channel, like the video and share to your friends. That will be encouraging to me to make more videos. Thank you.